All right, so today I want to talk about how to graph systems of linear inequalities, and we're just going to start very simple and then go from there. So this isn't really even a system, it's just one linear inequality, and it doesn't even have an x in it, it's just y is greater than or equal to 2. So what an inequality is like this when you graph it is you're just showing all of the places, all of the xy coordinates, where the y value happens to be greater than or equal to 2. Okay, so you don't need to write this on your graph paper, but you can imagine, like, how about this point right here at 3, 6? Is the y value greater than 2 there? Yes. So when we shade this in, we're going to be shading this in. That point should be shaded in. This point over here, the y value is also greater than 2. This point right here, the y value is greater than 2. This point right here. How about this point down here, this red point? No, the y value is -1 there. So anywhere in the red, anywhere I put a red dot here, the y values are all less than 2, right? Anywhere where there's a blue dot, the y value is greater than 2. And so you'll start to kind of see what this is going to look like. Basically, it's anything, just shading anything above here. Anything that happens to fall above this line right here, where y is equal to 2, we're going to shade that in. Okay, so I'm going to erase all these points real quick that I drew, and then we'll actually show you how to graph it. But I just want to walk you through what it is, why it makes sense. Okay, so we're going to go ahead and we're going to graph the line y equals 2. So I want you to think about y equals 2, what that would look like. That would just be a flat line, and it would have a bunch of points that go through 2. So let's go ahead and draw that line. Okay, so we'll draw this line sideways here. And so this is the place, okay? So anything on that blue line is the place in the xy coordinate space where y is actually equal to 2. Okay? We want to show visually all of the places in the xy coordinate space where the y value is actually greater than or equal to 2. So not only are we going to color that line in, we're also going to color everything above that line. So we'll literally just shade in everything above the line, and it's not going to look pretty because there's a lot of shading to do, but you get the point. We're going to shade everything in above that line. Okay, I missed some spots, but you can imagine literally any point that falls in there in this blue area, it will be true that that y value there is greater than or equal to 2. Okay, so that's a basic intro to how to graph one linear inequality. Let's talk about one caveat to this, and then we'll do some systems. So there is one thing I want to talk about, and that's a situation where you have y is greater than 2. On the last one, it was y is greater than or equal to 2. And so how do we show visually that we're shading everything above 2, but we're not actually shading 2? So let's go ahead and we'll get this line going here. And so the way that we show this is we just do a dotted line at 2 instead of a solid line. So what we're saying by doing a dotted line is that, hey, everything above 2 is fine. We're just not actually shading 2 itself. So we'll shade everything above 2. Okay, you get the idea. All right, let's do a system now. So, oh, by the way, so anytime you have, if you just have like a greater than or you just have a less than, you'll want to make a dotted line. That just indicates, hey, stuff on the line is not actually a solution, but anything above it is a solution. All right, so graph the solution to the system. So what we're going to do is we're going to do the red first, and then we'll do the blue, and then I'll show you how we get the final answer. All right, so the red one, y is greater than or equal to 2/3 x plus 1. So we have 1 here, and we're going to go up 2 over 3, because that's the slope. So we'll go up 2 over 3, up 2 over 3, up 2 over 3, and so on and so forth. And we'll go ahead and draw this line. It's going to be a solid line because it's greater than or equal to. Okay, so here's this line. And we're going to shade, okay, so are we going to shade above or below this? Well, this red line is the place where all the y values are actually equal to 2/3 x plus 1, and that's great, but we want to actually show all of the y values that are greater than or equal to 2/3 x plus 1. So not only are we going to shade this line in, we're actually going to shade everything above it, because if you think about it, like this point right here, the x value is 6 and the y value is 5. If you plug this in, if you plug in 5 for y and 6 for x, they'll be equal to each other. But what about if we go here? What if the x value is still 6 but the y value is now 6? If you plug in 6 here, is 6 greater than or equal to 2/3 of 6 plus 1? Well, 2/3 of 6 plus 1 is 5. So yes, 6 happens to be greater than 5. So what we do to show that is we just shade everything above this line here, okay? So if it's greater than or equal to, we're generally shading above the line. If it's less than or equal to, we'll shade below the line. And if you're not sure whether you shaded correctly, like whether we shade above or below, just pick a point and see if it works, right? So pick a point. If you grab a point right here, oh, didn't mean to highlight that, just meant to get a point. If you pick a point right here at 4, 6, plug it in, see if it works. If it works, it should be shaded in. If it doesn't work, like something over here, then it should not be shaded in. All right, so that's the solution. So what we've done is we've shaded in all of the places, all of the xy coordinates so far, where this is true. Now let's shade in all the places where this blue inequality is true. So we've got 2x minus 2. So I'm going to go down to minus 2 there and put a point. And now we're going to go up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, so on and so forth. Let's go ahead and draw that line. Okay, so we'll draw the line here. And this is less than or equal to, so we'll do a solid line here. And so this line here, this blue line, is the place where all of the x values and y values are such that the y is equal to 2x minus 2. So if you double the x value and subtract 2, the y value would be equal to that. Okay? We want to show all the places where the y value is actually less than 2x minus 2. So we're going to shade below here. So we're going to take the blue line and we're going to shade everything below. So we'll do that. And then what we're going to do now is, but to solve this system of inequalities here, the solution is the place where the xy coordinate pairs satisfy both the red inequality and the blue inequality. Okay? So let's take 3 examples. How about a point here at 1, 8? So 1, 8 satisfies the red inequality, but it doesn't satisfy the blue inequality. So 1, 8 is not in our solution set. If we pick a point here at 7, 2, that satisfies the blue inequality, right? It falls in the blue zone, but it doesn't follow, it doesn't satisfy the red inequality. It doesn't fall in the red zone. So this point right here at 7, 2 would not be in our solution set. But how about a point right here? How about a point at 7, 8? If we take 7, 8 right here, this falls both in the red zone and in the blue zone. And so this point would be in our solution set. In fact, anything that's in this little overlap area is in our solution set. So this overlap area is the actual solution set. Okay? So what we'll do to signify that is we will shade this solution set in here like really dark. So we'll shade this in like very dark. And so what that means here is that the actual solution set, and we should probably draw over these lines too, is anything either on these lines or in the black area that we've shaded in. And what's cool here is if you actually go in and try xy coordinate pairs like 6, 6, they work for both. And if you try coordinate pairs that are outside of this double shaded zone, they won't work, either for one of them or for both of them. Like if you try a point over here at -1, -1, it will work for neither inequality. So this is cool that we just have a visual representation of this reality right here. Okay, so let's try this one. So graph the solution to the system. We've got y is greater than or equal to 1/3 x minus 3. So let's go ahead and graph that. So we'll go down to -3. We'll put a point. And then our slope is up 1 over 3. So up 1 over 3, up 1 over 3, up 1 over 3. Let's go ahead and we'll go down 1 left 3, down 1 left 3. And we'll go ahead and graph that. And since it's greater than or equal to, we will do a solid line here. And since it's greater than or equal to, we're going to shade everything above this line. And I do want to make a comment here. Since you're probably using a paper and a pencil and you don't have a highlighter like I do on here, what I recommend on these is on one version, since you have a paper and pencil, shading one of these vertically and then shade the other one horizontally. Sometimes it helps you to see where the overlap of the solution set is. So I'm going to shade this in. Obviously, I didn't shade every single thing in. There are gaps, but those are all the places where the y value is greater than or equal to 1/3 of the x value minus 3. Okay? All right, how about the green inequality now? So we're going to take -3x plus 1. So we're going to go up to plus 1 there. And we're going to go down 3 over 1. So down 3 over 1. Down 3 over 1, down 3 over 1, and we'll graph this line and make sure when you do this line that you do a dashed line. Also, we can go up 3, left 1, up 3, left 1. So we'll do a dashed line here. So we'll do a dashed green line. All right. And now on this one, on the green one, it says we want all the y values that happen to be less than -3x plus 1. So the dashed line shows all of the places where the y value is actually equal to -3x plus 1. We want to shade below that. So like I said, on the orange one we shaded vertically. On this one I'll shade horizontally. And that just kind of helps me visualize where the actual intersection is and where the solution is for the system. So for the system here, I'm going to do like a purple color, and the purple color is everywhere where the orange and the green overlap. So that's going to be including this line right here. Everything basically up this way. So the orange and the green both happen to be colored in this purple section here. And I'm actually going to leave that green line there. This green dashed line, I'm just going to leave it dashed like that. And so the solution set then is this purple area right here. It's this boundary line, and then it's everything above that and everything to the left of this dashed green line. So if you happen to pick a coordinate pair over here, it would work in both inequalities. If you pick a coordinate point here, it would only work in the orange inequality. If you pick a coordinate point here, it only works in the green. And if you pick a coordinate point here, it doesn't work in either one. All right, so let's do one more example like this, and then we're going to do a backwards example where they give us the graph and ask us to write the inequalities. Okay, so last example here. Now, this is a system with 3 inequalities, which is fine. You can have a system of tons of inequalities if you want. So let's go ahead and show what the graph would look like for this. So we're going to have the red is y is less than or equal to 4. So that's just a line that runs right across 4 here. So let me get my ruler tool out and we'll draw that line. Okay, and it's less than or equal to, so we can draw a solid line here. And since it's less than or equal to, we're going to shade below that. Let me actually get a pencil out here so you guys can kind of get a feel for how how this would look if I was actually doing this on pen and paper. So I would shade below that line there, and I would do a horizontal shade. And all right, let's do the green one now. So the green inequality is y plus 3 is greater than x. So we actually have to get y by itself before we can shade this, before we can graph it. So let's subtract 3. Oh, I'm still writing with a pencil. Let's subtract 3 on both sides. So we now have y is greater than x minus 3. Okay, so now we can graph this. Y is greater than x minus 3. So let's go down to -3. 1, 2, 3. I think it's right there. It's kind of hard to tell with that pencil there. And what is the slope here? They didn't give us the slope, but you can imagine the slope is just 1 over 1 there. Okay? So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, down 1 left 1, down 1 left 1, down 1 left 1. And this is, when we shade this, it's just going to be greater than, so we need to do a dashed line. So let's go ahead and do a dashed line here. Okay, so we'll go ahead and draw that dashed line there for the green. And we're going to shade below here. So let me get my pencil out. And we'll shade below. And since I went vertical on that last one, what I'll do here is I will go... We went horizontal on the last one, so I'll go vertical on this one. So hopefully you can kind of see here that I've shaded the area that where both are shaded is this area right here. The area up here is only vertical, but the area starting below the red line and below the green line here has been shaded both horizontally and vertically. Okay, so this is the current solution set. If we just had the red and green, now let's add the blue. So y plus x is greater than or equal to 1. So let's subtract x from both sides. And what we have is y is greater than or equal to negative x plus 1, which is really saying the same thing as y is greater than or equal to negative 1 over 1x plus 1. And so what we're going to do is come over and graph that. So we'll go over to plus 1, put a point, and then we're going to go down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. And we will go ahead, and that's going to be a solid line because it's greater than or equal to. So let's go ahead and draw that in. And then we're going to shade above that. So here comes our blue solid line, and we're going to shade above it. And let me grab the pencil here. This is where it gets a little tricky when you have like 3 going on. So maybe on this one, I'll shade kind of diagonally, since I've already shaded horizontally and vertically. And hopefully you can see here that when we shade diagonally, this is only in the blue. This section right here hits the blue and the red. It falls above the blue, below the red, but it doesn't fall below the green. So the actual full-on solution set, so if I was doing this with paper and pencil, what I would do is I would shade in this area right here really dark, because this is the area where all 3 places have been shaded in. So I'm just going to shade in this area right here super dark. We'll just keep shading it and shading it and shading it. And so hopefully you'll see here in just a sec that this area is darker than anything else, and that's how we know that this is the actual solution set. Now remember, stay below that red line. We're going to stay below the red line, below the green line, and above the blue line. So this right here would be our solution set. All right, last problem. Okay, so now this one's a tough one. It says, write the system of inequalities that generates the graph. And so what we have here is we have a system of, it looks like 4 inequalities actually. There's a red one, a green one, a blue one, and an orange one. And what I've done here is I've highlighted points. So that black point right there is a nice point on the graph. That's a point on the graph. That's a point on the graph. Point on the graph, point on the graph, point on the graph. And so basically what's happening here is we've got the red inequality that we need to figure out, the green inequality that we need to figure out, the blue inequality that we need to figure out, and the orange inequality that we need to figure out. Okay, so let's start with the red one. So the red one, and this can be a little tricky. This is definitely going to test your algebra skills. So the red inequality, I'm going to say, has a slope of 1/2, because if you look at this point right here and then you go up to this point, you go up 1 over 2. So for the red, I'm going to say that we have a slope of 1/2. And now the question is, if you want to write it in slope-intercept form, y equals mx plus b, we know the m is 1/2. The problem is we don't know what the y-intercept is. At some point, this is going to cross the y-axis, and don't just trust me that it's right there at 5. It may be somewhere slightly different, okay? I just freehanded that, so I don't know. But basically, this line is, at some point, it's going to come over and cross the y-axis, so that's what that b is. Here's why I like point-slope form. I've told you in some of the other videos, I really like point-slope form because what we do here is we do y minus y1 is equal to m times x minus x1. And we can plug in a point that we know for sure is on the line. And as long as we know the slope and the point, so the y value of the point and the x value of the point, we can solve and write it in slope-intercept form. Okay, so let's do that. So we're going to say y minus, and we're going to actually pick a point that's on this line. Okay, so let's pick, in particular, let's pick this point right here. So this is at 4, 7. Okay, so it's over 1, 2, 3, 4, and it's up, I can tell, 7 there. So 7 happens to be the y value. This is going to be equal to 1/2 x minus, and we said the x value was 4. Okay, so now what we can do is we can actually go down and solve. We can say y minus 7 is equal to 1/2 x minus 2. So all I did was distribute that 1/2 there. I multiplied. And so now we're here. If we add 7 to both sides, we get y is equal to, add 7, y is equal to 1/2 x plus 5. So it actually does go through 5. It goes exactly right through 5. Okay. So I'm going to zoom us out here a little bit. Oh, that's not what I want. Let's see if I can grab something over here and zoom. Nope. Sorry. Okay, well, we're just going to have to roll with that. Okay, so at this point, yeah, there we go. This is what I wanted. So we've got the red equation is y is equal to 1/2 x plus 5. Now, it's an inequality, and it's getting shaded below that. Okay, so this purple shading happens to fall below this red line, and also notice how the red line is dotted. So our first inequality that we want to write, and I'm going to put them up here, is y is less than 1/2 x plus 5. That's our first inequality. Okay, they're not all going to be that hard, but there's a start. Okay, so that's the red one. Let's talk about the green one now. So the green one is a vertical line. So how do we write vertical lines? So how do we write the equation of a vertical line? Vertical lines take the form x equals some number. In this case, x happens to be 3. If I wanted just the line, I would say x is equal to 3, but since we're shading to the right of the line, think about this. Are the x values to the right of that line greater than or less than 3? If you pick the x values over here in the purple space, they happen to be more than 3, right? Here's x is 4 right here, 5, 6, 7, 8, 9, 10. So we're going to take x values that are greater than or equal to 3. That's the inequality there for the green line. Let's do the orange line real quick because it's very similar. The orange line happens to fall on, it looks like 6, so 10, 9, 8, 7, 6. It's kind of hard to tell where the 5 is exactly, but if you come over here, you can see that that's at 6. And so we're going to take x values that are less than or equal to 6 for that orange line, because this is the line x equals 6, and we're taking values to the left of that. So values to the left of 6 would be less than 6. Okay, so now the only thing we have left to do is this blue line. So I'm going to move us, I'm going to try to scroll, move us over a little bit. So for the blue line now, we've got, let's see if we can figure out the slope for the blue line. So the slope would be, if we take a point here and then take a point here, so we're coming down 1, 2, 3, 4 over 1. So the slope is going to be -4 over 1, which is really just -4. Okay, and what I want to do is I want to do the exact same thing. I'm going to do y minus y1 is equal to m times x minus x1. And what we're going to do is we're going to just plug in a point for the x and the y values here, and we're going to put -4 for that slope. So let's pick a point in specific that we want to work with. Let's actually do this point right here. So let's do 3, 0. So we're going to use the point. We know for sure that this line goes through the point 3, 0. So we'll do y minus the y value, which is 0, is equal to the slope, which we know is -4 times x minus the x value there, which is 3. So right now we've got the equation of this line in point-slope form, and then we can just switch it over to slope-intercept form. Okay, so we've got y is equal to -4x plus 12. Just make sure you multiply that -4 to both parts there. Okay, so -4x plus 12. So if we wanted the equation of that blue line right there, it would be y equals -4x plus 12, but we don't just want the line, we want everything above the line. So we want all the y values that happen to be more than -4x plus 12. So our final answer then, when we come over and write our last inequality, is we're going to say that we want all the y values that happen to be greater than or equal to -4x plus 12. That will shade above the blue. This will shade to the left of the orange. This will shade to the right of the green. And this will shade below the red there. And so that is going to be our final solution right over there. So we'll circle that. Put a nice big white box around it. So this is our solution.